All right, good morning. Thank you. It's a pleasure to be here. I'm Bill Snyder. I'm from SUNY Morrisville. I'm the professor of the fish and wildlife ecology over there. I'm not sure, am I batting cleanup or giving the benediction?
We're going to have a question and answer after you.
Okay. Anyway, I have to say, probably over the past 30 years, my classes have come to Cazenovia Lake and used it, but very incidentally. If anything, we've been running a few beach seines off the south end of the lake. I've known Thad for a long time, and I was really excited about the prospect of the electroshocking boat. And you know, I was very unfortunate what happened to Cazenovia College, but I am thrilled that the boat remains, you know, a resource for the lake. And that was, you know, a lot goes to the Madison County Planning Division for making that happen. All right, Thad was able to provide me with a little over 10 years of data, about 10 years of data from 2012, predominantly trap netting data. And then that would, from September and October, some electrofishing data that we collected. So my goal here was basically to begin to get an insight into what is going on in the lake fish-wise, with predominantly with the largemouth bass. So, first thing I did was I basically only looked at fall data, so that I wanted to try to look at fish sizes in the time where they'd be about the same in the growth cycle each year. And so that during this period from 2012 to 2013, bass were collected as small as about 2 inches up to about 17 or 18 inches. 300 millimeters right there is about 12 inches. So the majority of them were in this harvestable size class, or, you know, targeted size class. What you're seeing is anything that is in the darker brown is the electrofishing data. So that was just this fall's data, and that compares to this tan, which is trap netting data, which represents about 8 or 9 years of trap netting data. So two things that I find interesting here, well, that you can see, is the greatly increased efficiency of catch that we will get with the electrofishing boat. We're getting a lot more fish, a lot fewer hours out there, and it's a lot more fun. Good science is always fun. The other thing that popped out, you can see that, yeah, we're still dominated by this cohort that's right in here, and I have absolutely, well, don't have much of an explanation why the trap netting picked up a lot of fish in that size class. Electrofishing tends to be broader in its selectivity, that we can get a broader size class. Trap netting, you're really getting those fish that, you know, are moving and will move into a trap net. And also, typically, you're looking at, when you get the bass down between about 8 to 12 inches, that's when they form large predatory schools, and they will travel a lot more. Once they really start getting 12 or 13, they start breaking down. So my guess is, you know, why did we catch so many right there, or if that catch so many right there, was just their behavior. But that's a scientific guess. Now, one thing I did was, we do something in fisheries called modal analysis. Fish get really distinct growth periods during the summer and not during the winter. So we can typically look at cohorts will tend to clump out. So bear with me, the data is really light. I would not, you know, put too much on this, but we can still see fairly distinct clusters here, 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 and here. And so forth. Now, offhand, I might want to say, that, we would very confident in saying these were the 2023. I would expect to see about 2 to 3 inches of growth on those bass the first year. Shoot at about 3. So the arrows down at the bottom, these are growth points that I've summed up over the past 40 years of just expected growth in northern climates. So a largemouth bass by the end of its first growth season should be about 3 inches. by the end of its second growth season, I would expect to see it somewhere around 6 to 7 inches and so forth. There's about 12 inches and on up. So without looking at scales, I don't know, but I'd have a tendency to say that we're seeing better. I mean, just again, cursory data, back of the envelope sort of estimations here. Looking at that tends to point to better than expected growth in the lake. You know, the lake is in great condition, and whoever keeps the list of vegetation, I want to get that, because boy, I'm not somebody who runs around and chases butterflies with a net. I go out and collect aquatic plants and press them. So, but there's some I'm missing out there. Okay. Now, after looking at those, I tried to break it down. I looked at largemouth bass and some of the predominant prey species. There's something we use in fisheries biology called proportional stock density, where we look at the total number of spawning fish, adult fish, and for largemouth bass, that's at around, they will start spawning at around 150 millimeters, about 7 or 8 inches, and then at 300 up. And this gives us a target range. For our predators, we like our proportional stock density to be around 40 to 60. And again, we took, this was just the electrofishing data. We took a very large number of nice bass, what we consider quality, what an angler would be happy to take. Trap netting is remarkably the same. Again, that possibly because they were targeting more of those schooling, traveling bass. But when I combined them, we hit about a 71%. So a little bit over the 60% max that we like to see. But again, this could simply be sampling an artifact, a statistical artifact out of the times we're sampling and the techniques that were used. Beyond that, then, I looked at the top 4 prey species that we were getting there: bluegill, pumpkin seed, yellow perch, white sucker, and these were all high. I gave me a weighted prey. We like to see prey densities in about 20 to 40%. So this was astronomically high. And again, right now, with the limited amount of data that we're seeing, I would want to push that. I would want to say that's probably sampling artifact as well. We have, what we consider a target window of where we like to see our prey PSD between 20 and 40%, or largemouth bass between 40 and 60, and it is right now, with the data we have, it's falling up in this quadrant. But that quadrant, that's known as the balance of nature. And, which, when I see a plot falling up there, that's something that's tend to indicating a largely unharvested system, which kind of makes sense. I know that there are people that catch fish out of Cazenovia Lake, to eat them, but kind of the opinion that most of you that fish are probably catch and release anglers. Yeah, no, that's a safe assumption. So that really kind of supports that proposition. One of Dr. York's students some years ago did some relative weight analysis. I looked at their calculations. Relative weight is something where we have formula for what is the ideal weight. What should be the target weight at different sizes, so we can take the actual weight of fish, divide it by the ideal weight, express it as a percentage. And I like to see that between 80 and 100%. Over the dozens of lakes and ponds that I've managed over the years, I'm used to seeing largemouth bass largemouth bass WRs in the 60s. I mean, it's almost always low. Now, I want to point out, there's only 2 fish. But those 2 fish, wow, those are the fish I'm voting for. We did take some weight data. I do have more data, but unfortunately, I just did not have a chance to crank it out. There were very large pools of data available, 289 for bluegills, 78 for pumpkin seeds, and they are right on weight. I mean, just exactly where we would want to see them. But hopefully there will be more data pulling in on that. So just a few things that I can pull together here. Offhand, at first sight, and from the bass that I got to handle out there, they looked good. They looked rotund. They looked well fed. So, according to my histogram and that spurious or specious, I don't know which it would be, WR data, but my visual observation, my anecdotal observation, they appear healthy. They are eating. Okay. The PSDs are exceptionally high. Like I say, this could be due to low harvest pressure. Right now I'm leaning towards the statistical artifact. So my recommendation basically, and you probably like this, I hope you like this, is more of an increased comprehensive sampling. The time that we were out there sampling with the shock boat, we started in September. As soon as water temperatures drop, a lot of fish will start moving offshore. It's just fish biology. They do that. The best time to electrofish to get your highest yields and your most representative sample is during the summer when the waters are warm and at night when the fish will move up into shallower waters due to the lower light levels. So that's when we do most of our electroshocking, and I can't tell you how many times I have had police and ECOs called over me because there's some sort of strange poaching operation or alien invasion going on out there. So I would like, I would like to get out there when we can try to flesh this out. I would love to do stomach content analysis on these bass because I want to know what they're eating. They are eating. I want to know what they're eating. The bluegills we were taking, the pumpkin seeds, are big. The white suckers we're taking are big. What I'm not seeing in our samples there were the smaller fish, the forage size fish. Once a fish gets, bluegill or pumpkin seeds gets over about 3.5 inches, it's getting removed from, being an elected prey item, something that the bass would really choose. I would be interested. And possibly we can set up something where that if there are people that are harvesting largemouth bass for food and filleting them, if we could collect stomachs, that I could see what's in there. One of the problems here is we haven't really used a method that would collect the smaller fish. We took a few golden shiners, which are, a good prey item. In my sampling hollows down there, I've taken a lot of banded killifish, which would be a good prey item. But again, we haven't used a sampling technique. So again, maybe more seining during the summer, nighttime seine hauls to try to fill in and see if they're there. One day when I brought my students up this fall, well, a couple of days when I brought my students up this fall and Thad had them on the shock boat, I was out there doing plankton tows. And I was very interested to see that. It's something you guys are monitoring. And an astronomical level of plankton out there. It is very healthy. A little water flea, Daphnia pulex, just dense. And I want, I don't know why we're not seeing like high levels of golden shiners out there feeding on them. They might be there, we just might not have sampled them. So that is something that I would like to target. And then lastly, just look at the scale data. Dr. York's look at the scales and the data that he has collected before, do a more comprehensive study to actually look at the fish and see if my modal analysis was close. So that's the direction I'm going, and I hope that Morrisville Environmental Sciences will be able to step in and help out with this some. One of the good news points on there is we have started a new Bachelor of Science degree that Right now it includes a 15 credit hour internship. I am writing a 15 credit hour research project that a student would do. So that possibly I could have a student who would be available all summer long to conduct said research out there. Okay. Is there any questions